guys hear me? Wonderful. All right, I'm Whit Whittall. I'm the program mentor at Colorado Space Grant Consortium. And so what I do is I teach project management and systems engineering skills to undergraduate students. For the past few years, or 2 years, really to be more specific, I have been working hard on a robotics workshop to replace some of our old electromechanical engineering curriculum, and I'm excited to tell you about it today. So how many of you have heard of Colorado Space Grant? Oh my God, that's more than I expected. That's awesome. Well, by the end of this, I hope you're all excited about Colorado Space Grant. Go home, chat a little bit about us with your colleagues. We are a NASA outreach program. We're congressionally mandated and funded, and our mission statement is to expand involvement in NASA projects and programs by enhancing science and engineering education. So what we're talking about today gets right to the core of that mission statement. We're working on improving our electromechanical engineering training in order to, prepare students better for our flagship projects and industry internships. So Colorado Space Grant spans the state of Colorado. We have people all the way out on the western slope in the San Juans. We excel at creating a pipeline from 2-year institutions to 4-year universities. Students come in, they may feel a little bit out of their depth at schools like CU or Mines, coming from community colleges, but if they participated in Space Grant before, that's a community they can jump into and feel like they're starting off on the right foot. So the Robotics Challenge is what I was really supporting with this mission. I think the Robotics Challenge is an amazing program. It's open to people from all of those institutions I just showed you on that last slide. We bring in teams of students from really any background. It doesn't even have to be technical. If they want to participate in the challenge, they're able. We give them an academic year and about $500 to create a robot to participate in this showcase at the end of the year at Great Sand Dunes National Park. So unfortunately my videos don't work, the rookie mistake. But this is an example of the kind of terrain we're talking about. We have natural materials. We're not allowed to mess around with the vegetation, too many of the rocks. So we don't even know what the courses look like on the day of competition. We show up, we find an area that looks good, set up some guardrails, and the students' robots have to be able to deal with that. So it's a very challenging project for a lot of these students, and we support them through that process with in-person mentorship from faculty at these affiliate universities and with design gate reviews. So in the spring and fall, I spend a lot of time on Zoom going through PDRs, CDRs with these students, giving them feedback on their designs and pushing them in the right direction. I think the Robotics Challenge is a really special experience for these students because it forces them to come out of the comfort zone of their degree programs. Robots, by their nature, combine electrical, mechanical, and computer systems. And so a huge challenge is integrating these disparate engineering topics and making sure that you can trace down bugs in your system. To do this, students need to adopt a systems-based design approach, which is not something I really had experience with in my undergraduate coursework until I got to Space Grant and began learning about systems engineering. A lot of students come into this challenge with very little mechatronic experience. And so we provide workshops in order to get them started off on the right foot. Before COVID, these workshops took the form of an in-person event here at CU. Got a lot of people who all traveled from all around the state of Colorado to come here and check out what we're doing. We utilized a simple SparkFun robotics kit that really focused on introducing basic event-driven programming skills with the Arduino microcontroller. During COVID, we had to take the workshop virtual due to safety concerns, and we figured out when we did that it was an awesome opportunity for our students distributed across the state. Before, it was primarily faculty coming to the workshop or people here in the Front Range. We have those people all the way out in San Juans and on the Western Slope who don't want to drive 10 hours or more in a day to come to see you, right? So this was the state of the robotics workshop when I became program mentor about 2 years ago at Space Grant. I pretty quickly realized, advising some of these robotics teams, that there were some issues, some gaps in the students' knowledge, things they had trouble with. Typically, that was the questions of like, how does the robot's body move when the wheels do something or other? How can we predict that? That's robot kinematics. It was also often, how do I estimate a power budget and create good design requirements that allow me to create a functional system? Knowledge of DC power circuits. Students had trouble grappling with how does the Arduino actually talk to those motors. Before, we had a off-the-shelf PCB that handled that whole integration component for us. And so in the workshop, we wanted to walk through that process with the students. We also have a lot of advanced robotics sensors that students want to use in the challenge. They have their own computer parts on those dev boards. And so in order to work with them with the Arduino, you need to network computer processors. You need to understand communication protocols. So this is what I wanted to do with the robotics workshop. I approached Barb and Veronica, my supervisors at Space Grant, and said, I want to produce a set of PDF lessons that we can distribute to our students across the state that cover these topics, with lessons on rover kinematics, power circuits, harnessing, motion control, finite state machines, and those network computer processors. I want to try and build these, T-shaped skill sets in students. So what I'm talking about is a person with a broad command of many different engineering topics, and then depth in one area that they can be kind of the subject matter expert to the team. These students are often getting that depth in their degree program, but they struggle with the breadth. And so that's what we provide. Early on, we started doing beta testing with some of our students at CU Space Grant. I would pull in a lot of my colleagues, say, do you have time from working on your project? I want you to come over here and build this workshop I've been working on and give me some feedback. And the results were pretty promising. So we brought on a computer science capstone team to enhance the workshop with interactive lessons and videos. This, unfortunately, is not a picture of our carpet. It is a video that won't work. But it shows our capstone students' rover navigating the space using a computer vision algorithm, and then scrolls through some of those Jupyter notebooks we're talking about. What we're doing is we're taking that lesson 6 that I didn't really talk about on the last slide, but is a overview of advanced topics the students may want to explore on their rover that they get to spend a year working on, breaking that out into specific workshops for students that are maybe returning to the challenge and have done this original workshop before. So we're really excited about the progress made through this workshop. It's a little early to provide much data on how well it's performing, but our computer science capstone team we work with was able to provide some web pages where we hope to host these workshop materials, make them a little bit easier to access than those PDFs. So we're hoping through that we're going to be able to gather more data on engagement and really draw some conclusions about how this workshop is benefiting students. We also want to bring back some of these in-person workshops, particularly for Space Grant faculty across the state. the mentorship, like the hands-on mentorship from the local space grant directors is extremely impactful to the students. And we want to enable these directors to provide the best mentorship possible. And so we want to give them opportunities to come to CU Space Grant and walk through these workshops with us, so that way when they go back to their affiliate institutions, they're best able to help their students. That's all I have for today. Are there any questions?
I've got a question here. This is so great with the transfer pathway, but I'm in the K-12 engineering education space, so what is the opportunity for getting young people, before they're even thinking about college, to be exposed to something like this? Is there something in Space Grant that's in K-12?
Did you hear the question over there? She was asking about a pre-college version of this workshop.
Thank you.
I love the idea of that. We've talked to people at the Challenger Center about the possibility of that, because they're primarily working with K through 12 students. This workshop that I've built is geared for college or dual enrollment high school students, because those are the people we have participating in our robotics challenge. And this workshop is designed specifically around that objective. But I would say a passionate advanced high school student, maybe not even, the word advanced is so vague, a passionate high school student could do this workshop if they set their mind to it. It might stretch them a little bit. I don't know how well I would have done with this in high school, but many of these students, the student who was the project manager on this particular rover, this was his first year in college. So I would say, and this rover is incredibly impressive. It's employing neural networks as a sensor fusion technique. It has a depth camera on board there, and so they trained it based on the data it's getting from its depth camera and its ultrasonic sensors to pick the best path through the obstacles in front of it. It's really cool. So that is an outstanding example of what these students are capable of if they're just, passionate enough to really try.
Okay, that's time. Thank you very much.